This is CPM Calculus Chapter 4, number 22. So we're given the value of the integral from 0 to pi of x times sine of x dx equals pi. So this can also be written as the integral from 0 to pi x sine x dx equals to pi. So this is what we're given. Right? That's the given in the problem. So part A says without a calculator, find, and we're given then two different integrals to evaluate. Let's do the first one. So let's call this A1 is 2 times, right? This is 2 times the integral from 0 to pi x sine x dx. So this part right here looks exactly like this part right here, right? So we know that that part is equal to pi. So this is just equal to 2 times, and we could rewrite the part here, right, as pi. Okay? And so let me write that a little neater, because that's the answer, is 2 pi. And it's exactly why, because 2 times this is equal to 2 times pi. Okay? So let's box our answer for part A. For part B, this one might be a little trickier just at the beginning. We're asked, what's the integral from negative pi to pi of x sine x dx? Okay, so what you have to remember here is we can split these up, right? We can split the region from negative pi to pi and just add the region separately. So we can say from negative pi to 0 of x sine x dx plus 0 to pi of x sine x dx, right? We can split this up because this is equal to just looking at the region from negative pi to pi, all right? So then we could go ahead and say, well, this right here we know exactly it's equal to pi. That's given, right? This is the same thing in our given function, right, in our given information. But this might be a little trickier unless you investigate more. But what we can do right away is see, well, can't I go ahead and change the direction of my start and stop indices, right? I can say, well, if I change the direction, that's going to be from 0 to negative pi x sine x dx, right? And then I have to go ahead and negate this, right? Because I can swap these two and then make it negative, right? So then we still, well, I'm not going to even rewrite this. I'm going to just call this pi, right? It's no longer in the integral. We know this evaluates to pi because that's what we're given, okay? And then what we know now is this is equal to negative. And if we were to evaluate this, okay, now we're going from 0 to negative pi instead of from 0 to positive pi. That's going to, so it's kind of tricky, but that's going to be, this right here is equal to negative pi, right, plus pi. And then negative times negative becomes positive pi plus pi. And that's 2 pi's is 2 pi, right? So a number 2 is also 2 pi because a number 1 is 2 pi, a number 2 is 2 pi. And let's go on to part B. Part B says to go ahead and use a graph to justify your conclusion. Okay, so B, use a graph to justify. Okay, so here if we want, we can use a calculator to look at this, because what we're going to see is that our function x sine x is going to be even, right? So let's go ahead and bring out a calculator and let's graph this, okay, because we have a calculator. Part A, we're not supposed to use a calculator, but part B, we could. X sine x, graph it, and there it is. And looking at the graph, you can see, right, so here's the graph. Here is x, let's say y is equal to x times sine of x. And we know that it looks like this, right? something like this, and like, oh, I can't draw that well, but it looks like this. It's basically a mirror image. Well, I'm really bad at right. This right here, our y-axis, is like a mirror. So this is how we can see it's even. If we could check that it's even too, is if we try, well, what is f of negative x? And that's just going to be negative x times sine of negative x. We know sine of negative x is equal to negative sine of x. That's a property of sine. And negative x times negative sine of x cancels out, so it's x sine of x. So therefore, if we plug in negative x, we know it's even. That's algebraically. And graphically, we can see it's even because right here on our y-axis is like a mirror. Okay? So why does that help us? Well, let's go ahead and look at part A again. Part A, remember, we're saying, well, given the information about x sine x from 0 to pi, what is 2 times it? Well, we know that that 2 is just going to vertically shift our graph a factor of 2 times, right? So every point is going to be multiplied by 2. Every point is multiplied. So it kind of just stretches it bigger, right, by a factor of 2. By a factor of 2, we know that then instead of just pi, it's going to be a factor of 2 of pi. So it's 2 of multiply is 2 pi. So that goes in, go ahead, that goes and explains our part 1 in section A. Part 2 in section A, well, if we can see going from 0 to pi, right, 0 and pi, I believe, is here. Well, let's check that. Let's go ahead and ask our calculator. F5 is math. Well, where is pi? So I'm going to say value and go ahead and second pi. Where is it at? Oh, it's right here. Excuse me. So this is not pi. This is pi right here. Okay, so then this would be negative pi, right? And then we can see that if we know the area from 0 to pi, so this area right here is equal to pi, well, negative pi to 0 is also equal to pi because it's even, right? This area is equal to this area right here. So that's how we can get this value in part 2 of part A, right? We go from negative pi to 0 is the same as 0 to pi. So that's just, we could even say, well, that's equal to 2 times 0 to pi x sine x dx, right? We can go ahead and skip all of this and write it like this. And that we did in part 1 of part A, was just 2 pi as well, okay? So looking at the graph should help because we know the area under the curve is going to be the same here as it is here. And that's going to end part B. Okay, so this ends CPM Calculus Chapter 4, number 22.